So welcome back. This afternoon we're going to move into a new lesson, but it's not going to be too different. We're going to write the linear equation in what we call slope-intercept form. So actually we're not going to be graphing any this time. We're just going to rewrite an equation in what we call slope-intercept form. Remember, slope-intercept form is when you have that equation y is equal to mx plus b. So basically what we're picking up on is, to be in slope-intercept form, we have to solve for y. So a few little steps here. In solving for y, the first thing we want to do is we want to zero pair that x term. The next thing we want to do is probably multiply or divide, that concept. If we see multiplication, divide. If we see division, use multiplication. So we want to use that inverse operation concept between that multiplying and dividing to get y by itself. So let's look at this first linear equation. I have this 5x minus 3y is equal to 15. Again, our methods to get y by itself is to first zero pair the x term. So I want to make this term zero out. Since it's a positive 5x, we want to use a negative 5x there. But remember, since this is an equation concept, to keep that equation balanced, we want to also put that negative 5x on this other side. So we now see that this 5x and negative 5x are going to zero out. This is going to give me then my negative 3y is equal to then, and these aren't like terms, you have negative 5x and a 15. I usually put the x term first and the constant second. So from there, we now want to get rid of this negative 3. So this is where we want to use this inverse operation. Since we say that multiplication, we want to divide this by negative 3, but we also need to divide this side by negative 3. So we have to divide each term by negative 3. So it's kind of a distributive property. You know, we're actually going to divide that whole thing by negative 3, but we just kind of divide each individual term by negative 3 is how it plays out. So the negative 3's will divide out. That's going to give me my y. And then we know that a negative and a negative actually simplifies to being a positive, so I'll leave that as 5/3. I'll go ahead and just make that a coefficient. So I'll go ahead and bring the x out to the side there. Make that a coefficient. So I have 5/3 x, and then negative 3 does go into 15 negative 5 times, so I make that a minus 5 there. And that would be solved for y, and that would be our slope-intercept form. So if we wanted to graph it, we would see that our y-intercept is a negative 5, and we could use that slope of 5/3 to graph some more points and draw the line. But this is all they are looking for, is just putting it in what we call slope-intercept form. Let's look at this next equation. I have 7x plus 5y is equal to negative 20. Again, we want to solve for y, so we want to zero pair that x term. So since I see a positive 7x, I want to use a negative 7x to zero that out. So the 7x and this negative 7x, they're going to zero out. I can mark those out. I now see that I have a 5y, and those aren't like terms, so we have a negative 7x and a negative 20. So I can just put those two terms down next to each other, a negative 7x and a negative 20. Now to get the 5 by itself, since that's multiplication, we want to divide each term by 5. So again, the 5's are going to divide out. I have my y there by itself. I really can't do anything with this, so we just write this as negative 7/5, and I slide that x out to the side there. So I just write that as negative 7/5 x. But I can divide 5 into negative 20, and that would make that a negative 4. So I have y equals negative 7/5 x minus 4, and that would be our slope-intercept form. So this is where we cross the y-axis, that's our y-intercept, and then that's our change in y and change in x, that's our slope. So we've done our job, we've got our equation in slope-intercept form. So we may try to do a few more of those examples, so stay tuned. We'll see what we have there.